Hello Year 10s who have missed today's lesson by either being on DV or in the school production. What you've missed today is electrolysis of solutions. Alright, now we started this a little bit in class the other day. What we're going to be doing here is we're going to be trying to predict what happens when you electrolyze aqueous solutions. Now we started this the other day, and what I said is that if you have something like this, sodium chloride, so that's table salt, sodium chloride, and you have a solution of it, alright, so AQ, aqueous, inside the beaker you would have sodium ions, you would have chloride ions, and the water in the solution actually provides H plus ions and OH minus ions. So water, H2O, a few molecules, it's like 1 in a few million molecules actually split apart, and they give you ions. So water is basically H2O, all right, we all know that. But some water molecules inside a sample of water will be H plus and OH minus. So if you've got sodium chloride solution, you actually have these 4 ions. And what I'm going to just grab here, unfortunately I haven't got the electrolysis kit. Bear with me for a sec, just moved away. Right, so I'm going to show you what I mean by this. There's some water. This has got mainly H2O, but it's also got some H plus and OH minus. They're sitting in there. And here's some sodium chloride, some table salt. I tip this in. I dissolve it, give it a little bit of a stir. So I've just put this sodium chloride ionic substance in there, this ionic lattice. I've stirred it. So what I'm telling you now is inside this beaker there are sodium ions, chloride ions, H plus ions and OH minus ions. They're all sitting in there. All right. So we know that when I turn on some electricity, if I was to put 2 graphite rods in there and electrolyze this, so if I was to do, so I'm just going to move further down the page, if I was to take this beaker now that we know contains all of these ions, and I was to zap it with electricity, there's the positive electrode, the negative electrode, that's the anode, we did this last time, and that's the cathode. All right, if I zap this with electricity, the positive ions will be attracted to the negative cathode, and the negative ions will be attracted to the positive cathode. So I turn on the electricity, the Na plus and the H plus will both be attracted to the cathode, so I'll write that underneath. And the Cl minus and the OH minus, because they're negatively charged, will both be attracted to the anode. Hopefully you're fine with that. And this is because opposite charges attract. All right, what you need to know in this situation is, out of the sodium plus and the H plus, which one of these actually gives us a product? And out of the Cl minus and the OH minus, which one of these actually gives us a product? Because, I'm telling you now, only one of them will give us a product. So, let me explain that. We know that sodium plus and H plus are both going to go to the cathode. So the question I'm asking you is, are we going to form sodium or are we going to form hydrogen? Alright, that's question number 1. And the second question is, when I look at the negative ions at the anode, am I going to form, in this case, chlorine, or am I going to form something from the OH minus? All right, so these are the questions that we need to answer. All right, we'll come back to this sheet in a minute. I'm just going to give you now 2 rules, because this is all about being able to follow 2 very straightforward rules. All right, so rule 1 and rule 2. Rule 1, if the metal is more reactive than hydrogen, then hydrogen forms. Hydrogen being H2. The reverse of that is if the metal is less reactive than hydrogen, then the metal forms. Now I know there's quite a lot of words there, but it's very, very straightforward when you see it in practice. Rule 2 is if the negative ion is chloride, bromide, or iodide, just these three, then you'll make chlorine, bromine, and iodine. Very straightforward. So if it's chloride, bromide, or iodide, you'll make chlorine, bromine, or iodine. If it is any other negative ion, then oxygen forms. You heard me right? Oxygen. All right, they're the rules. You need these, you need to learn these. So, rule 1, if the metal is more reactive than hydrogen, then hydrogen will form, H2. If the metal is less reactive than hydrogen, then the metal forms. And then rule 2, if the negative ion is Cl minus, Br minus, or I minus, you will make chlorine, bromine, or iodine. If it's anything else, then you make oxygen. Okay, so let's go back to our first example. All right then. And then we're going to do a few more, and that'll be the end of the video. All right, so what I've got over here then. So I'm going to deal with what's going to happen here. I've got a metal and hydrogen. So this is my metal and hydrogen rule. I've got sodium and hydrogen. So my rule says if the metal is more reactive than hydrogen, then hydrogen will form. Well, I know that sodium is really, really reactive. But let's just prove this on a reactivity series. It's from your textbook. There's sodium at the top. Hydrogen's right down the bottom. So sodium is more reactive than hydrogen. My rule says that means hydrogen will form. Sodium is more reactive than hydrogen, so hydrogen forms. So I'm going to carry this on down here. So you're going to make hydrogen. Hydrogen will form, not sodium, and that's going to form at this electrode here. All right, now I'm going to look at the other rule. I've got chloride ions and OH minus ions. My rule is if it's chloride, bromide, or iodide, if it's Cl minus, Br minus, and I minus, you make chlorine. Well, I've got this. I've got some Cl minus. Look, there it is. So I'm just going to simply make chlorine. So in this case, if I electrolyze sodium chloride, I will make hydrogen and chlorine. No sodium at all. No sodium will be formed. I will make hydrogen and chlorine. All right, you okay with that? We'll do a few more examples and then you will be okay with it. The final thing, because we're in triple science, we need to write the half equations at the end. This also applies to double science higher paper. All right, final step to do then. We know that we're going to make hydrogen, H2, and we know that it's going to come from the H+. We've written some of these in class. We will need two H pluses if we're going to make an H2. Here we go, two H pluses, two of these little fellas here. Two H pluses, and here's an H2 over there. All right. To turn two H pluses into H2, you're going to have to give each of these H pluses an electron. So that is the half equation. I'm not going to do any more on this video about how to write those. We've done some of these before. So the positive ions gain electrons. When a positive ion gains electrons, this is called reduction. All right, on this side, we know that the Cl minuses will form chlorine. Chlorine is Cl2. You're going to need two Cl minuses. The negative ions will lose electrons, 2E minus. That's the half equation for that side. If you sort of got a bit lost at that bit, don't worry. By the third time we've gone through, hopefully you'll understand it a bit better. All right, let's do a few more examples then. Okay, we'll do some of the examples we did in class. Keep following this video. All right then, so say we had copper, sulfate, solution. All right, solution, H+, OH-, sulfate, SO4 2-, copper is Cu2+. You would probably be given that in the exam. So here are the ions I'm dealing with. I'm going to circle my positive ions and bring them over that way. I'm going to circle my negative ions and bring them over that way. The positive ions will go to the negative, so they'll go to the cathode. The negative ions will go to the anode. This is all worth marks in GCSE. All right, first question, will I form copper or hydrogen? All right, have a little look. Reactivity series, copper is below hydrogen, so I'm going to form copper. All right, cool, I'm going to form copper. All right, and then sulfate or hydroxide. Well, my rule on this is if it's chloride, bromide or iodide, I make chlorine, bromine or iodine. I haven't got any chloride, bromide or iodide. If it is any other negative ion, then you form oxygen. Cool. I'm going to make oxygen. So I now know that if I electrolyse copper sulfate solution, I will make copper and oxygen. That's quite surprising, but pretty cool, and it's correct. All right, final thing then. Let's write some half equations. Copper. Copper is Cu, and it comes from the Cu2+. Get used to this. The positive ions always gain electrons, so they gain 2e-. Squish that in there. That's the half equation for the formation of copper. Gaining electrons, reduction is gain. And we know that oxygen is going to form. Oxygen is O2. And this oxygen is formed from the OH- ions. So I'm going to do that. The half equation for this, you just need to learn. The way it works is 4 OH- ions are attracted to the anode. They form oxygen gas. The hydrogens over here from the OH- end up in water. We make 2H2O. Oh, I've gone off the page onto the desk, but hopefully that'll do. And 4 electrons are left on the electrode. So let me write that one out again, nice and neat. 4 OH-, because we're going to need it again and again, form O2, 2H2O, and 4 electrons. Not that neat, but there's the half equation. You need to learn that. All right, if you're watching this from my classes, I'll just say learn that. If you're watching this from anywhere else, just learn that equation. If you have aspirations to get the top grades, that is the half equation for the formation of oxygen in electrolysis. All right, copper sulfate solution. Let's do another one. Let's go with lithium carbonate. Solution. Just making these up. Solution is H plus and OH- from the water. Carbonate is CO3 2-, lithium is Li plus. Li plus, H plus, down, down. All right, so CO3 2-, OH-, down, down. Lithium and H plus are positive, they're going to go to the negative cathode. These are going to go to the positive anode. Lithium or hydrogen? Okay, so lithium is more reactive than hydrogen, so you will make hydrogen, carbonate and hydroxide. If this is chloride, bromide or iodide, let me have a look. No, it's not. It's not chloride, bromide or iodide, therefore the OH- will form oxygen. Cool, are you getting the hang of this yet? All right, so I'm going to form hydrogen from the H+, 2 of these 2e-, there's your level 9 stuff, and you're going to form oxygen, O2, from, okay, it was 4 OH-, wasn't it? O2, 2H2O, 4e-. I've learned that already. Okay. Final one then. Silver chloride solution. Now, good chemists amongst you will know that you can't actually get silver chloride solution, but it doesn't really matter. Let's go through it in practice anyway. If you had silver chloride solution, which you can't because silver chloride is insoluble, let's see what you'd make. All right, what's going to be made? Silver or H+? You tell me. I'm going to pause for a minute. You don't need to pause the video. Just have a look at those. I'm going to just sit here for 5 or 6 seconds while you choose what's going to be made. Don't know that's you, but it was jolly, wasn't it? Ag plus and H plus. Right, silver is less reactive than hydrogen, so you're actually going to make silver. Chloride or hydroxide. Chloride is chloride, bromide, or iodide, so you're going to make chlorine. If you do silver chloride solution, you'll make silver and chlorine. Cool. Well, there you go. That was nice. Silver is Ag, and it comes from Ag+, so that means the Ag+ must have gained an electron. Chlorine is Cl2, comes from Cl- up here, 2 of them, 2e-. This is what you've missed in today's lesson. the ability to predict products from solution electrolysis. The class today did about 4 or 5 examples. I showed them some electrolysis today actually happening. So I took this salt solution, sodium chloride solution, and I showed them bubbles of sodium chloride. I showed them bubbles of hydrogen and chlorine gas. All right, it was quite cool. I'll show you that on Monday. But hopefully this nice little way of doing it really makes it clear. This method of doing this was shown to me, I mean, I've been teaching for years, but this was shown to me last week by Miss Barker. So credit to her here. I really like it. It's nice and visual. Makes it quite straightforward. Okay, enjoy your DV. Hope you don't get too wet. See you next week.